Hello and welcome to Mclean 360. In this video, I explain to you Newton's second law of motion. Okay, so we want to say that the second law of motion came as a consequence of the unbalanced forces or the force which arose from the first law. Ideally, the second law reduces to the first law in the absence of the unbalanced force. Okay. Now, to understand the second law, Newton introduced the concept of momentum, which is the product of mass and velocity. According to Newton, he is saying that force is experienced whenever there is a change of momentum over a time range. The shorter the time, the higher the force generated, and vice versa. So that is what we are saying right here. The force which is accompanied by acceleration. So what Sir Newton is saying that to be able to understand how a force is generated, he did understood momentum by saying that, okay, so momentum is the mass times the velocity of a body. Now, as you begin to change this quantity called momentum with respect to time, we generate what we are calling force. And so the quantity called force is nothing but the rate at which you change momentum with respect to time. The shorter the time, the higher the force. And then the higher the time, you're going to get less force. So let's understand momentum. Consider a vehicle of mass 1,000 kilograms moving with a speed of 2 meters per second. What is the momentum of this vehicle? So that is the vehicle right here. The momentum of this vehicle is going to be 1,000 times 2, which I'm going to get 2,000 kilogram meters per second. Similarly, let's say I have a bullet of mass 0.2 kilogram moving with a speed of 10,000 meters per second. We will also have the same momentum. Don't forget that 0.2 times 10,000 is 2,000 kilogram meters per second. Interestingly, it means that this means by any time you will experience the same force. And so if this bullet of mass 0.2 is coming with this very high speed, Newton is saying that the effect that the bullet will have on you is the same as a vehicle of mass 1,000 moving at a speed of 2 meters per second. Interesting, isn't it? Now, mathematically speaking, what Newton is saying is called force is actually K d mv dt. So the K is more or less the constant of proportionality, because we said the force is proportional to what? The time rate of change of momentum. And so mv represents what we are calling linear momentum, which is the product of mass and then velocity. In this case, linear velocity. Alright. Now, since mass is constant and non-zero, then force is going to be km dv dt. It means I will bring mass outside the derivative sign. Newton now calls the rate of change of velocity with respect to time as acceleration. And so Newton is saying that this quantity here, dv dt, is what? Acceleration. With that in mind, then I can say that F equals kma. Alright. Now, when K is chosen to be 1, we have what we call kinetic units. Now, kinetic units simply means units which combine to give us kinetic quantities. Don't forget that a force is actually a kinetic quantity. And so that is kinetic units. Then I'm going to get the famous equation in engineering mechanics, which is force equals mass times acceleration. This is the very most, famous equation, one of the important equations in mechanics. Now, that is to say that the sum of all unbalanced forces will give rise to an accelerated motion. Let's look at something interesting here. A equals dv dt, right? And so when v is equal to 0, put v equals 0 here, you have acceleration to be 0. And once acceleration is 0, once you put acceleration 0 here, you get summation of forces to be 0. It means that when a particle is at rest, then it means that the sum of all the forces acting on the particle is 0. That's the meaning. Secondly, when v is constant, put velocity equals constant here. In fact, v is velocity. What is the derivative of a constant that is actually zero? It means that when a particle is moving with a velocity which is constant, then acceleration is zero. And when acceleration is zero, the sum of forces acting on it is zero. Are you seeing what I'm seeing? It means that whenever a particle is at rest or moves with a constant speed, its acceleration is zero, and then the sum of forces acting on it is equal to zero. Now, it means the first law is a classical or special case of the second law. It means that when velocity is zero or constant, the second law reduces to the first law. This is very, very much interesting. Let's look at some practical application of the second law. So the rate at which you change momentum with time is proportional to the force acting on you. So this is David and Goliath. Now some of the Christian scholars are saying that David understood mechanics, and so he was trying to hurl around the stone, and he was able to generate a larger force by changing the velocity of the stone. And so when he threw it at Goliath, it had a very great impact which penetrated into his head. Rocket propulsion. And so with rocket propulsion, we are saying that there are burning gases coming out from this rocket, and these burning gases, they have some rate of change of momentum, which will further help this gas, rocket, and propel it upwards. To understand this, I have also explained it in the third law. Okay, but this is the second law. So for now, let's take it as this. Then when you get to the third law, you get a better view of what we are saying right here. So there are two ways to state the second law. Either you say that the rate at which you change momentum is force, or you can also say that summation of external forces equals mass times acceleration is the same thing. So this means to accelerate a body, subject it to unbalanced forces. So simply put, force equals mass times acceleration. Therefore, acceleration is force divided by mass. It means that acceleration is inversely proportional to your mass. So bodies which has very small mass can be easily be given higher acceleration. That's basically what we are saying. Now, all dynamic system design, from vehicle, aircraft, missiles, satellites, they are also submarines, are all designed using the second law. And so we are looking at all the forces acting on them. A typical example is the aeroplane. So before they design the aeroplane, they look at all the forces acting on the aeroplane and look at all the force balance and analysis on the aeroplane. And then to know the acceleration, you sum all the forces and you equate it to mass times acceleration. You'll be able to get the acceleration. Thank you for watching.